Greetings, growers from around the world. Jordan River here, back with more GrowCast, skunky and funky and ready to broadcast. Today we've got Nick back on the line, continuing our nutrient deep dive. You guys love Nick. He's from Rooted Leaf Nutrients, rootedleaf.com, code GrowCast always, and we are continuing our nutrient deep dives with sulfur. This episode is awesome. It's going to change the way you look at sulfur. I know you're going to love it. Before we jump into it with Nick, though, shout out to AC Infinity, baby. ACinfinity.com, code GrowCast15 to get your savings and keep the lights on here at GrowCast. We appreciate your support, and we love AC Infinity. They make the best grow tents around, extra thick poles. They've got nice, durable, thick siding. Now they have the new side ports. People have been asking for those, and AC Infinity, listen. Plus, they've got everything else you need to grow. They've got lights and pots and fans and their oscillating fans, the Cloud Ray system. Check out their humidifiers, the Cloud Forge. How nice is your humidifier? Maybe it's time to replace that. The Cloud Rays are my favorite oscillators on the market. And of course, their Cloud Line series, what they got it all started with. All those years ago when we were partners with AC Infinity, all they made were those inline fans, and they're the best in the game. So shout out to the entire AC Infinity suite. They've got everything you need to get growing, from fans to tents to lights. Code GrowCast15 works at acinfinity.com. You support us, and you're getting some badass, durable grow gear while you're doing it. So thank you to all you listeners using code GrowCast15, and thank you to AC Infinity. Okay, everyone, let's get after it with Nick. Thank you for listening, and enjoy the show. Hello, podcast listeners. You are now listening to GrowCast. I'm your host, Jordan River, and I want to thank you for tuning in again today. Before we get started, as always, I urge you to tell a friend about GrowCast. Share this show. It's the best way you can help us out. Get someone growing. We've got a whole new mission for Overgrow planned that you guys are going to love. And to see everything that we're doing, go to growcastpodcast.com/action. There you'll see all the action, the seeds, the membership, the classes, everything. And give us a good rating and review on the app that you're listening to. We really appreciate those. Thank you so much. Today, we are continuing our nutrient deep dive. That's right. We've been diving into specific minerals, going deep. You guys know that I love these deep dives. And today we are on a hot topic, if you will, sulfur. That's right. This episode's all about sulfur, and who better to discuss the role of sulfur in our gardens with than Nick from Rooted Leaf. What's up, Nick? How are you doing, man?
Hey, what's up, Jordan? I'm doing pretty well, man. How are you?
Doing excellent. Doing very, very well. Loving these nutrient deep dives. They've been getting great feedback. If you haven't heard the other ones, listener, you can go back to nitrogen. And then we did an episode on calcium that might be my favorite, and also a very strong episode on potassium and magnesium. So listen to this one or catch up and enjoy these nutrient deep dives. Of course, Nick from rootedleaf.com, he activated code GrowCast. You can save 20% on your nutrients. Thank you for doing that, Nick. You've been a busy guy, though. You've been all over the place, right? I mean, you were traveling around, traveling out of country. Tell us about your travels.
Yeah, I had a crazy month of May, man. I went to Florida at the very beginning of the month. Part of it was to check out a watermelon farmer that we're going to be working with. And then I also wanted to meet up with the flower farm. Shout out to Mike. We didn't have a chance to meet up, but we definitely will next time. I've got a very good reason to go back. He's a super cool dude, and I enjoy talking to him. I was also in Florida to do a TV show called Elevator Pitch, and it's kind of like Shark Tank. I had a chance to pitch, in front of the former founder or former CEO. He was the first CEO and one of the founders of Netflix. So he's kind of a very popular, very famous dude, good investor. Can't tell you what happened quite yet. No spoilers.
I was going to say, you can't say how it went, can you? I want to know. I want to know what happened.
No, I unfortunately can't say anything quite yet, but the episode does air in a couple of weeks. So they have a pretty quick turnaround time from what I understand, and hopefully beginning of June to mid-June, we should have the episode aired.
All right, I'll check that out. We'll put a link to that on the GrowCast site. Shark Tank with Nick. I love it.
That's right. And so the day after that, once I came back from Florida, I had to fly out of country halfway around the world to the country of Azerbaijan. And I stayed in a city called Baku, which is the capital. Beautiful region. Spent about a week there as part of a U.S. trade mission. We got some support from state and federal government agencies to kind of go out there and, try to sell our fertilizer and develop some stronger relationships between the U.S. and Azerbaijan. And
sending
the thing that I
fertilizers from here out to there. That's amazing.
Yeah. And part of it is it's kind of a little bit larger of a project overall. It's going to include a little bit of trade, obviously, but really it's about just sharing the connections and the ability to grow healthy crops. One of the things that really stood out to me during that travel, during that visit, was that, as you know, our manufacturing plant is here in Washington State. And a lot of the tree fruit growers, because apples, for example, are a big industry, same thing with like pears and peaches, persimmons, pomegranates, they grow a lot of hazelnuts, strawberries and tomatoes, things like that. And, Washington State is actually considered a very famous and popular growing region across the US. A lot of people would consider it, for example, the mecca of apple production, or tree
Sure.
fruit productions. So we go to these very large facilities, multi-million-dollar operations on hundreds and hundreds of acres. And as it turns out, every single one of the business owners or the agronomists had at one point flown out to Washington State to get a feel for how things are done here. They even brought back and imported a lot of the varietals that we grow here, and a couple that were even developed here in Washington State. So
Wow, all the way out there. You were in Azerbaijan, and they go, oh, you're the Washington guy. You're the Apple place. That's crazy.
yes. Yeah. They were like, okay, you manufacture fertilizers in Washington. We respect Washington, and you're here with the federal government. You must be
Damn, dude.
legitimate. So
That's so
it
cool.
wasn't a hard sales pitch at all. Yeah, they were actually very open and curious to better ways of doing things because they're tired of getting fertilizers from the countries that they're currently getting them from. They are not very happy with them. So, but
Wow.
yeah, part of it too is just this larger effort to strengthen the relationships that the United States has abroad, specifically for not only like actually supplying fertilizer, but just the general, practice of growing healthy crops and
Yeah,
for,
no, I get that, right? Sending over our guys. I'm sure you talked about carbon over there, and you were, dropping some knowledge. I'm sure you learned a lot over there. That's really fucking cool, dude. I think that's just awesome.
yeah, it's a pretty nice area and the food is incredible. So I'm
I
gonna
bet.
do a little compilation video, and hopefully at some point in the future we can do a little bit of a Growcast TV session. I'd love to show you guys some of the footage. It was freaking amazing.
Oh, absolutely. Yeah, good call. We'll do that on Growcast TV. For the members out there, we're live every Wednesday on TV, and Nick has done some amazing episodes. If you're a new member and a new listener, go back and listen to the Growcast TV episodes with Nick. Some of those are really, really good. We kind of fill in a lot of the stuff in between these episodes on the main podcast on that show. Really cool, dude. Godspeed. Keep us up to date on all those relationships. That's really, really neat. And you got to tell us how the fucking reality TV show went. So we'll talk about that.
Oh yes.
But for today, man, let's jump right into it. You want to talk sulfur? Jesus Christ, sulfur is such a huge subject on my show, and I need 45 minutes plus with you just about sulfur. Are you ready to rock?
Yes, I am. I think sulfur is very appropriate after we did that magnesium and phosphorus combo episode. A little bit different than the PK booster, but for the next one being potassium, I think we're going to have some good connective tissue between the three of them. So I'm happy to do
So
sulfur right
cool.
now, and it's kind of out of order, but I think as people continue to listen to these, they'll understand the sort of journey and the path we're going down. So yeah,
I
I'm
like the
definitely
order.
excited.
It's better than NPK, okay? So for the sulfur, man, let's start where we always start. Before we get into specifically cannabis and all that, how does sulfur act in nature? How does it move and run off? And how is it taken up and utilized by plants traditionally?
That's a great question. And, sulfur in its sort of natural form, it kind of follows the same theme or pattern that we've seen with a couple of these other elements that we've talked about. We look at CO2, for example, in nature that has the oxygen molecules attached to it. We look at nitrates, which are NO3. Those also have oxygen attached to them. And so too does sulfur, because most of the time plants take up sulfate, which is SO4. Now you have CO2, NO3, SO4. All of them have the same problem, which is, hey, the plants don't need that oxygen. So as we've gone through in the past, when we start with nitrates, plants will reduce them down to their ammoniacal forms to make amino acids. And plants will reduce carbon, for example, to make monoterpenes.
Mm-hmm.
And as it turns out, plants will also reduce sulfates to make these things called thiol groups, which are very, very important in nature. And they're important constituents of amino acids, and they also kind of help define and regulate redox systems, which we'll kind of get into a little bit. But yeah, the
Ooh.
predominant form out there in nature for plants is sulfate, and it kind of has to go down this pathway of being reduced, just like carbon, just like nitrogen. Sulfate is reduced. It takes a couple of steps, and then when it's finally ready in its final form, it gets inserted into cysteine, which is an amino acid, and it becomes the thiol group itself. And then from there, that's sort of the starting point. You could call that the terminal reduction point of sulfur in nature. When plants take it up, they reduce it, and that reduction terminates in the biosynthesis of cysteine. From there, things start to get built up, and plants can make a variety of different sulfur or thiol containing compounds, a lot of which are found in
Interesting.
cannabis and have been actually studied just recently. So,
Exactly. So I don't know where I want to go with this quite yet, because there was a lot of talk about the pop culture and skunk smell. Let's save that for just a second. I didn't know that thiols played more of a role than what I've just recently heard them brought up in, which is this argument over aroma. So thiols are important, is what you're saying.
yeah. And, a lot of people know what antioxidants are. They've heard of that general concept. But I would say sulfur is quite literally the defining antioxidant system, or, reduced sulfur in the form of thiol groups defines what antioxidant systems are. There's something called glutathione inside of plants, and it's an enzyme that deals with reductive and oxidative stress. It can kind of cycle really quickly between the two of them. This thing is vital. It's a kind of a defining factor of plant activity, because if you think about what the chloroplasts do and what plant cells are, they're always exposed to in sort of a chemical state that's out of equilibrium. They always have light energy shining down on top of them, and their metabolic processes revolve around dealing with that light energy. If you put the light energy too close to your plants, you'll burn them, right? Because there's too much of that light energy, and that creates oxidative stress. So the whole purpose of plant metabolism is actually to kind of balance these states of being reduced and oxidized, and these antioxidant mechanisms help create that buffer, help create that balance. If you knock a glutathione out of a plant cell, you have no plant cell, because the plant cell is incapable of balancing and buffering, the reductive versus the oxidized states, and the whole cell just breaks apart. So without sulfur in the form of a thiol group, you wouldn't be able to even have complex life. The system is actually very tightly preserved in nature across all plant species. I think if you were to knock glutathione out of any plant cell, doesn't matter if it's cannabis or corn, wheat, soy, you wouldn't have a plant cell anymore. It's very tightly and tightly controlled and tightly regulated across evolutionary history. Now, I will say real quickly too that C3 plants actually have a slightly higher need for sulfur metabolism over C4 plants, and that has to do with the carbon concentration mechanisms. But generally speaking, for C3 plants, they'll produce a variety of different sulfur-containing compounds, which we can get into as well.
Well, that's cannabis being a C3 plant. That's one of the reasons why cannabis eats so much sulfur, right? I don't want to put any words in your mouth, but my understanding is that sulfur is in demand with the cannabis plant. How much does cannabis eat when it comes to sulfur, and what roles does it play with our plant that we're concerned about?
That's a good question. I think a lot of times people, and the reason that I wanted to do this after the magnesium and phosphorus episode, we kind of talked about this myth of a PK booster, and I almost feel like the trend right now in the industry is to over-fertilize with sulfur. I call it the PK Boost 2.0. It's like the next wave of, I found the thing that, is going to maximize my yields and so on and so forth. The point ultimately is that most of the sulfate you give your plants ends up contributing to maintaining a state of balance. And that's the thing. You can't push that state of balance out of whack, because then you start to get problems with the plants. There is such a thing as too much sulfur and sulfate. It starts to actually reduce the levels of phosphorus within the plant's phosphate, because it kind of has that same similar charge and it competes. And then the other thing too is that sulfur ties up really quickly with calcium in the soils. So a lot of times before you actually see the detrimental biological effects, you actually start to see some precipitation in the soil, and you start to see pH rises, for example, as the calcium sulfate starts to accrue, which is just gypsum. I think a lot of people that are in living soils naturally emit it anyways. But the point is that it takes a while to break down because it's not soluble. And that's a problem for calcium nutrition.
Right. Which is something that the plant is chewing through a lot of, is that calcium. They're unalike in that manner, right? Sulfur isn't being sucked up, put into the cell walls constantly chewed through.
Exactly. It's useful for its electrochemical properties. And, as a constituent of the cysteine amino acid, or sometimes when that amino acid is inserted into a protein, it becomes the cysteine residue. Thiol groups are really good at just switching between the reduced and oxidized forms. And the best way that I can explain that to someone is if you've ever had curly hair, that curl in your hair is a result of disulfide bridges, which is sort of the oxidized form
Is that
of
right?
thiol groups. Yeah. They don't break apart. They're highly reversible changes that happen. So think about it like this: the light energy from a plant's perspective, it's coming in at the speed of light, right? I mean, the plants have to deal with photon energy as fast as that photon energy comes in. But they have these enzymes on the other hand, like rubisco. We've talked about rubisco.
Hmm.
It sort of sucks CO2 out of the air, and it makes sugars and it makes terpenes, or the building blocks, I should say, sort of long, far down the chain. But nevertheless, they're still precursors, right? These are all substances the plant has to act on. That happens at a much slower rate of speed. The turnover for rubisco may be 3 seconds, but the speed of light is much faster than one photon every 3 seconds.
Wow.
There's millions, if not billions, or even trillions of times of a difference there. It's not a small difference. And so what happens is the plant has to say, okay, how do I coordinate these two things? One of them comes in at literally the speed of light. The other takes 3 full seconds to turn over. What do I do in between? And the answer to that is create redox pools. You can store up that energy and pass it around a variety of different systems. And this is where, glutathione comes in. It can kind of help create this balance and this buffer. It sort of soaks up all of this oxidative stress, and it can donate electrons in a reversible way very quickly. So when enzymes, for example, need energy, it can say, here you go, I have some stored up energy. Or if there's about to be some oxidative stress that happens to like the chloroplast, for example, or some of the pigments, a lot of these antioxidant enzymes and mechanisms that utilize thiol groups, they're capable of absorbing that. They can become oxidized without breaking, and then they can become reduced without breaking. These two states are highly reversible, and they can happen pretty much just as fast as the oxidative stress comes in. So,
And sulfur is okay. So now I'm understanding how much of a role sulfur plays in this redox potential, which you've talked about before, the constant oxygenation and then deoxygenation of a variety of life on this planet. That is very, very interesting. Now, where does this play out? And again, with what we care about when it comes to aroma, flavor, yield, how does this tie into cannabis's results?
well, there was a really good study that was done back in, I think it was at the end of 2021. And this group of researchers wrote this really, really nice paper. They had identified new volatile sulfur compounds that were present in cannabis plants that resulted in the characteristic skunk smell. The thing I want to point out real quick, though, is that when we're talking about these sulfur compounds, the volatile sulfur compounds, they're detectable in the parts per billion. So they actually make up a very small percentage of the overall aromatic profile. And then same thing with plants besides cannabis, which also produce like onions, for example, and garlic and cabbage.
Mm-hmm.
They produce certain types of sulfur-containing compounds, but they too are at very, very low levels overall. So sulfur itself is not considered when we talked about calcium, for example, I said, think about calcium like a macronutrient because plants take up huge quantities of it. With sulfur, it's not necessarily the case.
Mm.
When plants take up sulfur, they can kind of rely on one, pool to deal with because it can convert back and forth, back and forth. It's always kind of there doing its thing. When plants take up calcium, they bury that calcium in the cell walls. Now they need more calcium because they're always making cell walls. So
Chewing through it.
sulfur is recycled within plants to that extent. It's useful for its electrochemical rather than structural properties. So sulfur is not required in very high concentrations. And in fact, it's best to consider sulfur the balance of sulfur to nitrogen. You kind of want to maintain a particular ratio, about 10 parts nitrogen for 1 part sulfur, somewhere to 15 parts nitrogen to 1 part sulfur is kind of the range that you see in nature.
Wow, that's a lower amount of sulfur than I may have anticipated. And it's interesting that it's such a small part of the aromatic profile. Now, are you saying that that's kind of a miscommunication, or are you saying that small part plays a big role in how we perceive it? Does that make sense what I'm saying? Like, does the sulfur really contribute to this skunk smell? Do you think that adding sulfur to a skunk strain might pronounce that skunk smell, or is that not the case?
Yeah, I think so. I think cannabis plants, even though they produce volatile sulfur compounds in a detectable range that's expressed in parts per billion, which is like very, very, very small, it's still perceivable on the nose. It still has a very strong and pungent odor. And a lot of the compounds that are found in cannabis are also found in allium species, garlic and onions, things that are known to contain powerful sulfur compounds. It's the exact same ones. It's just found in higher concentrations elsewhere. Now, there are some novel sulfur-containing compounds besides just those that bear that thiol group, which is fully reduced sulfur. There's some that have sulfide groups, for example. There's some cannabinoids that have thioesters inside of them. So you have this sort of broad range of possible metabolites. And I should mention too, actually, to sort of piggyback on top of a question you asked earlier, one of the other roles besides just antioxidant defense systems that sulfur can play in is the plants produce these compounds called phytochelatins, which are like chelating agents for heavy metals. And so a lot of times when plants have to deal with excess heavy metals being present in the soil, they can actually produce sulfur-containing compounds that bind up with that heavy metal and prevent it from accumulating within the plant tissues. So, there's an example of how a little bit of extra sulfur to help relieve stress can help the plants, even though it's not that primary antioxidant mechanism that I mentioned earlier.
Wow.
It's more of like a heavy metal binding type of property. And above and beyond that too, there are volatile sulfur compounds that play a role in both attracting pollinators and deterring would-be predators. It's kind of a nice mix of the two. And if you wanted to get even a little bit more complex, there are some allelopathic compounds, which means that one plant produces it to ward off another plant. Maybe the roots of this one plant are getting too close to you, and so you decide to produce some volatile, sulfur compound or just a soluble sulfur compound, and introducing that to your neighboring root system makes them grow away from you.
Wow. So it's kind of used as a weapon. Sulfur is a potent and how do I put this? It's kind of a harsh substance, right? Like we're going to get into spraying sulfur in just a second, but before that, I gotta touch on something you just said, man, because I think that this is an important point, and I want your take on it, which is, we talk about the terps, like the terp profile. What's the terp profile? It's almost synonymous with aroma and flavor, right? And we know that terpenes do play a huge role in that, in what you're experiencing. But how many other compounds are there that contribute to aroma? How many compounds are there that we haven't really even nailed down yet, do you think, that contributes to aroma? Because when I would study coffee, that's what we found, right? Is there's all sorts of stuff that contributes to aroma. You talk about the thiols, you talk about different acids, you know what I mean, contributing to aroma. I know that's the case in coffee. You tell me, are we over focusing on the terps a little bit? And this has just kind of become synonymous with what is a broader picture, which is the true aroma profile.
Yeah. And I would say if you look at, terpenes themselves, terpenes come from pathways that give rise to other types of compounds. So there's connective tissue between all of this stuff, flavonoids and terpenes and fatty acids and so on and so forth, phenolic compounds in general. They all have a relationship at some point in their biosynthetic pathways. So yes, the complex aroma of cannabis is due to compounds that are not going to be found when you go and send off your flower for analysis at a lab. They're just going to kick back maybe a list of a dozen or so terpenes and maybe a handful or two of cannabinoids. But in reality, there are hundreds of compounds that are responsible for the characteristic aromas. And even within a single trichome head, you may have thousands of different compounds. Again, a lot of them are just derivatives of each other. Some are oxidized forms of each other. When you scope your trichome heads and you see that kind of cloudy, milky, maybe amberish color happening, you're really looking at this chemical soup of compounds. It's not just like one terpene or two terpenes. You're looking at hundreds, if not thousands, of different compounds that exist in varying states of each other. Some are more oxidized. That's why they look more amber. Some are a lot more reduced because the terpenes literally just minted them 2 seconds ago.
Jeez.
A lot of them are a week or two old. It's such a complex thing. So there's this like constant, it's never just a still snapshot. It's more of like it's a movie rather than just a single picture. You're looking at something that's in motion.
I love that. And it's so cool when you're scoping those trichomes after listening to an episode like this, because I like what you said in a previous episode, which is I look at these trichomes now as little factories. The factories at work here and going up and down the trichome stalk, and you can look over the individual factories and see how they're all operating a little bit differently. And they're still on their way to where you want them to go. But like you said, this one's more oxidized. So now it's amber, and you're putting together in your head what that means with the additional oxygen and the degrading of the degrading of THC into CBN possibly. It's just really cool to have these types of discussions and then get in there and look with this new understanding.
Yeah. And a lot of times these sulfur containing compounds that are going to be found in the trichome heads, again, even if they're in the parts per billion, the point is that they can kind of soak up this oxidative stress that would otherwise cause degradation of some of the other compounds. And so that's an important characteristic here. Even though I do think that a lot of people apply sulfur in excess, there are certain conditions maybe where you're trying to stress the plant out, where a little bit of extra sulfur isn't going to harm the plants. But like I said, if you just look out in nature, there's this ratio of nitrogen to sulfur that most plants try to maintain, because the point is ultimately sulfur is useless unless there's an amino acid that can incorporate it into that cysteine form, which is an amino acid. So you have to have this relationship of reduced nitrogen in its ammoniacal form, bound with reduced carbon in an organic acid form. Those two make an amino acid. And now, on top of that, you layer a third reduced form of sulfur, which is in the thiol group. And so cysteine is a really interesting amino acid because it represents a plant's flow of energy to reduce the nitrogen and to reduce the carbon and finally to reduce the sulfur. So this thing is like very tightly regulated and coordinated in
Doing
nature.
A lot of
Plants
work.
use it as
Doing mad work, as they say.
Exactly. And it represents just so much stored energy because, reducing nitrates takes a ton of ATP. Plants obviously use the power of the sun to reduce carbon, and now they're trying to reduce sulfate as well. So to them, it's a pretty important high energy sort of deposit that they have to make. And again, it's used as a buffering agent. So the last thing that you want to try to do, if you give something to a plant to help create balance within the plant, the last thing that you want to do is give it so much that it throws it out of balance. That kind of defeats the purpose of the balancing act.
That makes sense. That makes perfect sense. Now, you gave a range, nitrogen to sulfur, somewhere between 10 to 1 and 15 to 1. And I know you said that's what exists in nature, but it made me think about how, I don't know if I could say there's one mineral that plants feed on differently the most, if that makes sense. But one thing I've noticed is a cultivar in my tent getting really hungry for sulfur, especially during that stretch period, right? Like you flipped and your plant's stretching out. Sometimes I see that sulfur just being super, super necessary for one cultivar. They seem to feed differently, is what I'm saying. And I know that's the case with every mineral out there, but is that something you've observed, like one cultivar chewing down on sulfur, whereas another one didn't need it?
Yeah. I think some plants, part of it is just the sulfur cycle too, because not everything that you give your plants is going to be taken up. Like if it binds out with calcium in the soil, like we had talked about earlier, that sulfate is going to take months to break down. So, you could be thinking in your head, I'm going to give it this amount of sulfur, but not all of it works its way into the plants.
That's true. Yeah, that's a good point.
That's an important consideration too. Yeah. But, the other thing too is that even though sulfur is recycled within plants, you're right in the sense that it can go outward. It kind of branches outward from its core function as an antioxidant, which literally defines antioxidant systems and prevents plant cells from dying. It starts there, and then it kind of branches out into secondary metabolites, like we had mentioned with certain types of cannabinoids, even certain types of terpenes may contain sulfur groups. Certain species of plants have different aromas that are characteristic of them, like onions and garlic, that are due to the sulfur-containing compounds. There's this broad range of functions, and so you can actually expand the overall aromatic profile by getting the correct level of sulfur. However, like I mentioned, it's such a small amount, parts per billion in some cases of some of these. And even when you add them all up, you're looking at maybe 1 part per million if you're, lucky. So yeah, in that case, in that sort of sense, sulfur is definitely required in much smaller quantities than people think. But adding it, particularly during times of stress, can certainly help the plants out in a number of different ways.
I think I've observed that in real time because I know how to stress my plants, let me tell you. What are you waiting for? Come join the Order of Cultivation GrowCast membership. We would love to have you in our amazing community full of positive-minded growers looking to uplift each other. GrowCastPodcast.com/membership is where you can find the Order of Cultivation. First of all, you get hundreds of hours of bonus content and live streams. You can hang out with me in the live voice chat, tune into GrowCast TV, interact with the show, get all your grow questions answered on the AMAs and in our members-only Discord. Plus, you get discounts on a whole host of items, discounts on classes and seeds. It's an amazing community, again, focused on lifting each other up as growers. We don't deal in divisiveness or jumping down each other's throats, criticizing grow styles, none of that. We are just here to help each other out in our garden and make a difference as a cannabis community. So come and check us out, growcastpodcast.com/membership. Try 7 days for free with our free trial. I know you're going to love all the bonus content, the interaction, all of our different regional chapters where you can meet growmies and go to meetups. We have a lot going on in membership, everybody. Come check it out. I can't wait to see you there. Try the 7-day free trial, and we'll see you on the inside at the Order of Cultivation. I do want to talk about sulfur from a phylosphere perspective, because we talk about adding sulfur to the roots and the need for nutrition and all of that, but a lot of people have something like wettable sulfur as part of their IPM regimen. This sulfur powder, you mix it in your pump, it clogs the fuck out of your pump, and you spray it on your plants. It's super, super effective. It's like my nuclear option kind of, killing bad pathogens, killing a fuck ton of different insects. How does that work though? What's the difference in how the plant is like taking up that sulfur on the leaf surface? How does that affect the plant when I drench it in sulfur?
Yeah, so wettable sulfur is a different form. Elemental sulfur, it's actually pretty stable, which is why it doesn't oxidize to sulfate. There are bacteria in the soils like Thiobacillus species, which can oxidize elemental sulfur and eventually get to sulfates, and at which point they're highly soluble and your plants will take it up. But on the leaf surface, it's a little bit different. You may not have Thiobacillus species like you do in the soil. It's a very effective tool for controlling any kind of fungal disease pressure, like you had mentioned. But I think for anybody that's tried any kind of hash or even flower that was grown with too much of a sulfur spray, you can definitely taste it. It does take a long time to break down because in its elemental form, it is stable and it won't oxidize all the way to sulfate, which is super soluble. And so plants can quickly deal with it, or, during the flush phase, or even if you wash your buds during that bud wash phase, the stuff can come off. Wettable sulfur, not so much. And it doesn't help that a lot of times those products have soaps or surfactants that are meant to kind of spread across the leaf surface and stick to it. So, in reality, you want to be careful with not spraying it too far into flower. I would say even like the last week of veg is kind of a reasonable cutoff point.
Right.
And not a super high dose because it does stick around.
It hangs around. I was just going to say, you see it on your plants, you see it in your tent, it fucking hangs around. That's a really good point. Early veg type product for sure.
Yeah. And I don't know if plants are necessarily equipped with the enzymatic tools to be able to process elemental sulfur very quickly. That's why it kind of hangs out and leaves that residue for so long. Plants are sort of unable to deal with it. And yeah, it does take a long time, even for it when exposed to oxygen and light. It can hang out for a while, and it takes a while for it to oxidize all the way to sulfate. And that usually doesn't happen spontaneously. You need some kind of enzyme within the plant or some kind of enzyme within the Thiobacillus species, as I mentioned earlier.
So you're not fixing your sulfur deficiency when you're using it. You're saying good IPM tool if something's basically what I was saying, which is like if you have an infestation, you might want to reach for this, but not your foliar for sulfur is what you're saying.
Definitely not. Yeah, definitely not. You're not going to get any kind of nutritional benefits. You may actually end up stressing the plants out, which puts them in kind of it's not that they're reduced in sulfur, or I should say, it's not that they're deficient in sulfur, it's that they're deficient in a form of sulfur, because that reduced form of sulfur will help plants deal with oxidative stress. And when you're looking at your plants and you can see them stressed out, there's oxidative stress, maybe some of the cells on the outer layer of the leaves have burst and you can see brown spotting or maybe curling and burning, all this stuff. It's a sign not necessarily of a sulfur deficiency, but the incorrect state of sulfur is being maintained. And plants are having trouble dealing with that excess oxidative stress. So there's a couple of things people can do. One is they can add more sulfur to their plants to help build up a pool of reduced sulfur to help deal with that stress. Or in most cases, people will just remove the stressor. Maybe they'll move their lights up 6 inches if they noticed, oh crap, my leaves are burning. So they move that up, it reduces the stressor. Now the pool of sulfur available within the plant can kind of return to its normal state, which is more reduced than it is oxidized. Plants like to be and maintain that reduced form, preferentially because then they deal with the oxidative stress that's generated as a byproduct of just living life,
Yeah, man. I've seen that exact scenario before, right? Which is the turned up light, the stretching of the plant towards the light, and then that classic sulfur deficiency expression, or maybe I should say classic sulfur imbalance expression. So very, very cool. But yeah, I hadn't thought of that before with the wettable sulfur and the uptake of sulfur through the leaf. This is a bit of a left turn, but can I ask you quickly, what do you use for your IPM regimen? Like if you're doing a tent grow cannabis at home, what's your spray choice?
I like to use plant extracts, obviously, with good reason. I do think that there's certain products out there that work really well. I don't like to use any kind of like synthetic soaps or anything that requires an oil-based carrier. That just tends to mess with the natural chemistry of the leaves, and you kind of end up.
You were going to say that the horticultural oils are not your favorite.
No, they end up putting the plant in the middle of the struggle. If you kind of think about it, like if you've got a disease pressure, it's an insect that's attacking the plant. The last thing that you want to do is harm the plant in an attempt to harm the insect or to get rid of the insect. So, a lot of times, like with aphids, for example, actually one of the best things that I think is possible to do is just high pressure plain water. It's not within an aphid's normal day-to-day existence to deal with a jet stream of water that knocks it off the leaf surface, or even worse. I mean, you think about how powerful some of the streams just even coming out of your garden hose can be. You can put your hand in front of it and it can like exert a lot of pressure. So if you're just this small soft-bodied insect, that shit hurts, man. You get knocked around, and in some cases you get drowned, and it's just not fun for them. So
knock them bitches off with some, yeah, especially canopy aphids are just, yeah, that's the one you can just knock off. Maybe,
exactly.
yeah, a tiny bit of plant extract, huh?
Yeah. And some of our customers, they have really good IPM protocols that call for the use of certain types of natural oils and essential oil extracts, but none of them are really like soap based. They don't really need to do that. I'd say mechanical anti feedant behavior is probably best. First, try to get in there and actually disturb them mechanically and physically before you rely on any kind of horticultural oils. They're good and they have their place. Don't get me wrong. I think especially in large scale agriculture, it's hard to effectively control disease pressures like that. So you got to rely on some of the chemical options. It's just some of them are going to be better than others overall. Some types of saponins, for example, produced by like Quilaha, for example, I think people call it Chilean soap bark. It has good anti-aphid properties to it. And I think part of it is just the chemical structure of that molecule works really, really well to kind of maintain that disease pressure.
I've seen that. I've seen that before.
Yeah. And it's a natural saponin, so it is technically a soap. It is a compound that foams up quite a bit. Same thing with yucca root. Although yucca root doesn't have the same aphicidal properties, there are other compounds out there found in other species of plants that also, like sesquiterpene lactones, for example. Pyrethrins derived from chrysanthemum. Those are cool too. You could just brew up a chrysanthemum tea. And I'm not talking about synthetic pyrethroids here. I'm talking about using chrysanthemum flowers and just making a tea out of it and spraying it on your plants. Something like that. If you just get into the habit of going out and maintaining your garden, if you're maintaining a small garden at least, that type of stuff goes a long way and sort of ultimately prevents you from having to use synthetics.
Chrysanthemum tea from your own garden. Of course you're going to use tea. You son of a bitch. You snuck in the tea.
That's right. I had to give it a shout out somehow.
That's what's up, man. That's what's up. What can you tell me about the changes in need for sulfur throughout the plant's life cycle? Or is it pretty much the same and about maintaining that balance?
That's a good question. I think part of it comes down to how much stress you're going to expose the plants to. Because if you expose them to things like heavy metals, which we talked about earlier, maybe there's an increased need for sulfur metabolism in the plants. They'll just end up producing these phytochelatins, which will bind up and sort of prevent the heavy metals from being taken up. In some cases, as the plants stretch for the first 2 weeks of flowering, they get closer and closer to the light. That higher light intensity can cause an increase in the need for sulfur to be present to help deal with the stress that can arise of that. As a result of that, I would just say, like during periods of peak growth, the plants definitely need to be able to rely on their pool of available sulfur to help soak up any of that kind of oxidative stress. When they're young and they're just rooting out, they may not have such a high need for sulfates, and so a little bit would be plenty for them to be able to utilize. But certainly as they start like catching traction and they start growing rapidly, and maybe you're changing lights from T5s to metal halides during those transitionary phases where you kind of ramp up the light intensity, ramp up the fertilizer load, ramp up the environmental conditions overall, you're effectively subjecting your plants to more and more stress. And a lot of that stress can be positive stress. But as people have noticed, if you become deficient, not only in sulfur, but in any other element, the plant starts to show you signs of that stress.
Right.
So you have to kind of increase the nitrogen load, increase the carbon load, et cetera, et cetera. And it's important to pay attention to the role that sulfur plays in that transition to higher and higher stress levels. Ultimately, it's a good idea to do a little bit of extra. If you're the type of grower that adds a pinch of magnesium sulfate in every so often with your watering, add an extra pinch and a half next time you go from T5 lights to metal halide, or when you flip from veg to bloom, or maybe if you think that your soil is maybe a little bit hot in heavy metals, things like that can kind of go a long way to helping the plants relieve stress.
Such a cool way to think about it. So different than the other elements that we've talked about before as well. Like, it's a totally different perspective and approach with applying sulfur and why you need to apply sulfur and when you need to apply sulfur. So that is really, really eye-opening, man. What about situations with a lot of runoff? That is one thing we didn't cover. How mobile is sulfur? I remember you saying that things like nitrogen run off very, very easily and very, very far. Is sulfur like that, or does it kind of stick around?
Most of the sulfate species are pretty soluble in water, with the exception of calcium sulfate. You're looking at like magnesium sulfate, which is Epsom salt, potassium sulfate, which is a mine mineral. I think it comes in, a variety of different forms, different rock forms. Most of the stuff is pretty soluble overall when you start looking at it. But if you've got like, more or less slow release forms of fertilizer, like soil amendments, that stuff is going to take a little bit of time to break down no matter what. Most of the actual solubilized species, they're pretty quick to move through. So, if you're running a lot of Epsom salts through your grow medium, that could be a lot of sulfate coming out on the back end. But also keep in mind that if you see a rise in the soil pH, it's probably because there's calcium, presumably in the feed water mixture as well. When that calcium gets fed in conjunction with the sulfates, it can kind of bind up in the soil too, especially if you let the soil get really dry.
That makes sense. And I think that I've seen that before, with people who are relying on their soil for their nutrition and they're not adding any bottled nutrients, organic or otherwise. Sometimes when they get that runoff, they'll run out of some of the nutrition. And knowing that sulfur is soluble and it will run off, that makes a lot of sense to me. Now, which bottle of rooted leaf am I reaching for sulfur? Is that in your peak bloom?
We have a little bit of sulfur in peak bloom. Definitely the increase in sulfur metabolism is something that we've seen happens during the flowering stage. Obviously, the trichome heads start to form. You get all the secondary metabolic activity. And a little bit of extra sulfur definitely goes a long way. It's not an excessive amount. Lush green also has a little pinch of it. Lush green is a really small amount overall, though. And then also in the base nutrient side of primer A and B, we've got the stoichiometrically correct proportion of, nitrogen to sulfur overall. And I think it kind of works well in conjunction with the rest of the product line when, you think about sulfur being recycled and other compounds maybe accumulating within the plants in larger and larger doses like calcium.
Now, listen, you said that I didn't need the pH rooted leaf. I said bull honky. I tried it, and it's true. I'm loving using the rooted leaf in my indoor garden especially, but also I'm going to apply it to my outdoor garden where I just applied some worms for the first time. So fool me once, shame on you. No, you're telling me that now I'm going to pour these on my worms and it's not going to kill them and everything's going to be all right in my living soil bed outside?
Yeah, absolutely. We feed worm bins with our excess compost, which contains, like citrus peels and juniper berries and all this stuff. And the worms are huge. I see our products get used in living soils and the worms end up really, really liking it. And in fact, I can tell you from my personal experience, I've got a couple of house plants here and I have no idea how this happened, but so I feed them rooted leaf with every watering. It's been like this for like 3 years. I never give them plain water ever. Never have, never will. Just feed them rooted leaf all the time. And one of the flowers had all of these like carcasses that were hanging out on the top of it. It was like, if you looked at it from far away, it almost looked like little flakes of wood. But the closer you got into it, you saw that it was like little insect carcass, like the exoskeleton, the outer layer. And it almost looked like millipedes. And so I was disgusted with it for a while, but I ended up transplanting. I uppotted that plant recently and I found these huge worms inside it. And this is just a house plant. I found these huge worms inside of it. I have no idea how they got there, but they've been eating rooted leaf for like 3 years.
Whoa.
They've been in that soil. The soil is super well aerated. It's like super loamy.
Right under your
nose. It has a bunch of worm casts out of it. Yeah, and the plant is super happy. It's very healthy.
God damn, man.
The worms got moved outside.
That's fucking killer, though. They were right under your nose. Yeah, honestly, I was shocked by the no pH thing, and it really worked out well. So I'm excited to further test that, and just loving it, man. Now, before we go, I do want to ask you about applying my rooted leaf to other plants. It seems like this stuff is just, let her rip sort of thing. You just said I don't feed it plain water, just right on rooted leaf. But if I'm going out to water my chard, something that's going to grow leaves, or maybe water my tomatoes, something that's going to fruit, what do you recommend I do with the rooted leaf as far as feeding?
Any kind of fruiting crop like tomatoes, for example, they really, really, really like CalMag fuel. And I always like to add in a little bit of root anchor during the veg part of things. It multiplies the overall number of flowers that you get, and you get a ton of extra fruit as a result of this. This is actually part of the reason that we went to Azerbaijan is that we're working with strawberry and tomato growers. Those happen to be very, very large crops for them, very economically important crops. So, but it does. So if you use CalMag and Root Anchor on the veg side, you get a ton more flower sites. Like it's not just one or two extra. You get this multiplication factor. It's actually pretty impressive.
Fuck yeah.
And then I like to swap it out for resin bloom because it's also a potassium source. But once the flowers start blooming, a little bit extra resin bloom goes a long way. And then if you're growing something like tomatoes that has seeds inside of it, I always add like 1 to 2 mils per gallon of peak bloom, because 1 mil of peak bloom is 10 ppms of phosphorus. And so if I give these fruiting plants that are forming seeds inside of them an extra 10 to 20 ppms of phosphorus, it usually ends up going a very, very long way. That phosphorus gets stored in the seeds for the next generation, and the next generation becomes very, very healthy. Or the fruit just forms a lot better, and I end up eating it, and it becomes more nutritious for me.
Yes.
So that's usually the case.
Cannabis strength, I'm hitting them with my medium feed chart.
Mm-hmm.
Just rock and roll. That's easy. Sounds good to me. And then what about the leafy greens, non-fruiting plants? What am I hitting with my chart with?
Lush green works super well. Definitely a really good one. And then most plants, especially aromatic plants like basil, they really like foliar sprays of solar rain.
Oh yeah.
Light doses, 5 to 10 mils per gallon. They go nuts.
Forgot
and a lot of
the
them actually
rain.
really do like, solar rain's really good. Lush green, obviously for a nitrogen source, keeps them super happy and healthy. But you got to get a little bit of CalMag, and you got to get a little bit of potassium in the mix too. Solar rain does have some potassium, but certainly the calcium goes a long way, especially if you're trying to grow like cabbage, for example. A little bit of CalMag fuel.
Yeah, man. A lot of growers are excited about this outdoor season. GrowCast has been pushing the veggie side really hard lately. We've been giving away a ton of seeds. So I love taking these highly dialed in fertilizers, taking them out to the garden and seeing what they do to a crappy bag of garden soil from Home Depot. Like it's crazy how these organic fertilizers and cannabis practices, let's be honest, adding bokashi and worms and all this shit really transforms your garden pretty quickly, shockingly quickly.
Yeah, and you start to see certain types of characteristics and phenomena that maybe you don't see in plants that aren't so healthy. It's not like you just get a bigger fruit or a sweeter tomato or something like that. It's like the different morphological attributes of the plant. All of a sudden it looks gnarly and strong, and you don't have to spray any pesticide or fungicide on it.
Exactly.
For any kind of cucurbits, zucchini, cucumbers, things like that, you got to try a foliar spray of silica skin early in the season. If you're growing some cucumbers, for example, really early on, spray that plant when it's still young with silica, and it makes these crazy strong phytoliths. They're basically like shards of glass deposited on the outer layers, and you will not have any slugs at all. I would hate to be a slug crawling around on some of these really sharp.
It's crazy, man. I love it. We might have to do some veggie cast with Nick. Let me know what you guys think. We did a veggie cast, GrowCast TV for the members. I mean, it was a hit. Mary Beth Sanchez and Farmer John, I believe. But Nick, would you be down to do a veggie episode, either for the members or for this show?
Absolutely. That'd be a lot of fun. Veggies, fruits, things like that. If people got orchards, they want to grow some apples, let's chop it up. We'll get rid of the bitter pit and all of your problems, all the fungus gnats, everything.
That was amazing. Bro, this was an awesome episode. This sulfur exploration was great. I can't believe how much thiols came up during this episode, and that's exactly what I wanted. I also didn't know that they contributed so much to, the functions of the plant, and not just like, oh, that's what the skunk smell is. It's like, no, this is a major contributing compound when it comes to the healthier plant. I love that you confirmed the skunk thing and also said this is just a tiny little addition to the overall aroma that's still so detectable when you change it. And I also loved how you told us to think about sulfur as kind of an aid to the stressors. How much sulfur you're going to need? Well, how much stress is your plant undergoing? Get that sulfur balance right. You don't need to keep cramming it down the plant's throat like calcium, and just let it balance out and everything will be fine.
That's right. Yeah, I think we went through a lot of the good stuff, and I hope people have a better perspective on sulfur metabolism now. Please don't treat it like a PK booster 2.0. It's not going to, increase your yield significantly. It may broaden the overall expression that the plant has in its aromatic profiles, and it may enable the plant to better deal with stress, but it's not going to be the secret key that unlocks a massive yield. You're not going to go from 2 pounds to 3 pounds with, some extra magnesium sulfate or a little bit of, extra potassium sulfate. It's not quite how it works.
So next time, are we going to cover potassium? Is that what we can look forward to next?
Yes, absolutely. I think potassium is going to be a great episode right after this.
Awesome. We love it. We absolutely love it. Thank you, listeners, for tuning in. Once again, this nutrient deep dive continues. Find Nick at The Rooted Leaf on Instagram. Rootedleaf.com, code GROWCAST for 20% off your carbon-based nutrients. We appreciate you, Nick. Seriously, these episodes rule. Keep doing what you're doing with your TV shows and your travel, and most importantly, with the Rooted Leaf. Thank you, buddy.
Yeah, thank you. And thanks to all the listeners out there. Hope you guys enjoyed this one.
Got it, man. You know it. Stay tuned. Potassium next. And we got a ton of other episodes headed your way. Thank you, guys. Be safe out there as always. And of course, grow smarter. Bye-bye. That's our show. Thank you, everyone, for tuning in. And thank you to Nick from rootedleaf.com. As always, use code GROWCAST. Thank you for the savings, Nick. We can't wait to have him back on for more nutrient deep dives. Before we wrap it up, I'm going to tell you about GrowCast Seed Co. We have a special promotion going on. Find the rhinos. That's right, 3 rhino statues have been hidden in random GrowCast Seed Co. packs this month only. So if you go to growcastpodcast.com, you'll see the Seed Co. button. Click on through, check out our amazing genetics available to you. Free shipping right to your door. Members, of course, getting $20 off per pack. And if you find one of the lucky rhinos, you get a different, amazing prize. Find the little stone green rhino, and you'll get 5 additional GrowCast Seed Co. packs of your choice. Find the purple rhino, and you get 2 GrowCast Seed Co. packs, plus a microbiometer, brand new unopened. And if you find the transparent rhino, you get a clone of your own choosing from Farmer's Phenos. Shout out to Farmer John. This is a dope promotion, everybody. Check it out this month only. If you've been thinking about buying GrowCast Seed Co. seeds, run and grab them. growcastpodcast.com. You will find GrowCast Seed Co. there, and get those fire packs and look for those special rhino prizes, everyone. Thank you to Rhizo Rich at GrowCast Seed Co. All right, everyone, that's it for me. I am actually recording this after I got back from Pestapalooza. I'm so excited with the way things are going. And as I always say, I got some big things planned. If you've been following me for a while, you know that I mean it when I say that. So big things on the way. Thank you for being part of the GrowCast community. I love each and every one of you. See you next time. Bye-bye. Do you like GrowCast podcast? Of course you do. Well, if you love this show, you're going to love A Slice of Cannabis, a show all about food and cannabis, hosted by our good friends and members, Port and the Rugged Gent. What's up, Rugged?
Hey everyone, Rugged Gent here. If you're all about cooking, great cuisine, and cannabis like I am, then you've got to come subscribe to A Slice of Cannabis. We're free to listen to on Spotify or any podcast app, so come and subscribe today. Tune in to hear from world-renowned members of the cannabis industry as we explore the beautiful relationship between the food we enjoy and the cannabis we love to consume. Season 2 has just kicked off, so come check it out and catch up on old episodes with Jordan, friends of GrowCast, professional chefs, and much more. A Slice of Cannabis. Find us on Spotify or your favorite podcast app, and I'll see you there.
A Slice of Cannabis, everyone. Go and subscribe now.
Never give them plain water. Ever. Never have, never will.